Hello, presentation. This is day 8 of Summer School Algebra 1, PHS, day 8. What we're going to talk about today is exponents and powers and the rules of exponents. So it's going to be a lot of the 7 or 8 rules of exponents and powers, and I'm going to try and give you some intuition about why these rules are true, and then do a lot of examples. Lots and lots of examples. So it gets a little bit dry, but having a core understanding of exponents and how they work underlies some very important real world application of exponents. For example, in exponential notation. Exponential notation is one of the core ways that we do math in science. So understanding how to multiply and divide exponents is very key to understanding how we multiply and divide things in science, which is we do all the time. Okay, let's learn these rules of exponents and what an exponent truly is. All right, so what is an exponent and what is a power? These things are not exactly the same, but they're practically the same, and some people use them interchangeably. So let's first of all talk about the notation, and then we'll talk about what this notation means. So the first thing is when we see something like this, we say 2 to the 5th power. We say 2 raised to the 5th power. Or 2 to the 5th. That might be the shorthand way you'll hear it. Now, when we talk about this, before I tell you exactly what it means, let's just talk about what the pieces are. 2 is the base. We call that the base, and the base is 2, and that's the number to be multiplied a repeated number of times. So that's our base, and so that's 2. 5 is the exponent, and that's the number of times to repeat the multiplication. And then the whole thing, when we refer to the whole thing, we say 2 to the 5th, that's the power expression. So that's an expression that is the power. So the whole thing together is the power. 2 is the base, 5 is the exponent. Sometimes people call 5 the power, and as far as I can tell, and as far as I know and have been trained, 2 to the 5th, the whole thing is the power. And some people get a little bit confused, but to be exactly precise, let's know what our exponent is, our base is, and then what our power is. Now, what does it mean? If 2 is the number to be multiplied a repeat number of times, and 5, the exponent, is the number of times to repeat the number of the multiplications, 2 to the 5th means 2 multiplied together 5 times. So 2 times 2 times 2 times 2 times 2. Let's do 2 more just to make sure we really get it. So if 2 to the 5th means 2 times 2 times 2 times 2 times 2, then x to the 3rd means x multiplied together a certain number of times. It means x times x times x. And then our final example will be something just to make sure you really get it. If I said AB to the 4th power, that means the thing inside, the base, AB multiplied 4 times. In that, we have 3 examples of what a power means. This is the definition of a power. Okay, so now let's go on to our rules and how to apply our rules. And we're going to do a number of things. So we're going to talk about these 7 rules. So if you learn these 7 rules and how to apply them, you've learned everything there is in the lesson. And it's kind of confusing to some at first, but then it starts to make sense as we start to practice. So the product of powers means if I take a number to one power times a number to another power, the answer is just that number to the power added together. So for example, 2 to the 3rd times 2 to the 2nd equals 2 to the 5th. Not 2 to the 6th. You don't multiply your exponents. You add your exponents when you take a power multiplied by a power with the same base. All of these, many of these imply the same base. Okay, so be careful. If it's all x's, like here we have an x and here we have an x, this rule is only true when the base is the same. Okay, now let's look at another thing. Let's say we have a product of powers. This would be an example. Well, let's replace our variables with numbers. So 3 squared, or let's write this one over here. So we can write it bigger. 3 squared to the 5th. That's going to equal, well, what's the rule say? If I take 3 squared and raise it to the 5th power, that's going to be 3 to the 10th. It's a times b in this case. In this case, here's an example. If I have, now we say a number times another number to the a power is that number to the a power times the other number to the a power. So this would be 4 times 5 squared. It's the same thing as what? X to the a, 4 squared. And we're going to go over all of this in much more detail. 5 times 5 squared. This is a combination of rule 2 and 3. So this says if I have, 2 cubed times 3 squared, all of that to the 4th power, then that equals 2 to the 3 times 4, 2 to the 12th times 3 to the 8th power. Those are equivalent. Now we get into our quotient rule, division. So here, if we take 2 powers, and again, I'm going to go do one slide on every single one of these. That equals 5 cubed. If we divide powers with the same base, we just subtract their exponents. If we have 2 numbers divided, 4 fifths squared, that's the same thing as the numerator to the power to the exponent divided by the denominator. What's the denominator? And then finally, we have a combination of rule 2 and 6, which says that if we have 2 cubed over 5 squared all to the 4th power, we just multiply our powers together like that. So those are our 7 rules. Let's go over each one of them in more detail right now, one at a time. And then so what I'm going to do is I'm going to give you the rule. I'm going to give you 2 examples, or 1 or 2 examples, and then we're going to do I'll give you some intuition, and then we'll do some problems. So here's the product of powers. If I take a expression, 2 expressions with the same base, and multiply them together, I just add the exponents. So 2 to the 2nd times 2 cubed is 2 to the 5th, and x cubed times x to the 4th, again, same base. You just add the exponents. And some people want to multiply. Some people want to say, well, because this is all multiplication, I should be multiplying my exponents. And that's one, don't make the mistake. Don't make the mistake of multiplying exponents. And I'm going to show you why. Whenever we do these rules, you can always reverse the power, and you can see and test your answer. Everything we do today, you actually don't have to know anything but the definition of powers. You don't need to know any of these rules, and you can always deduce or build the rules by starting from scratch. What do I mean by that? Let's look at 2 squared times 2 cubed. equals 2 to the 5th and see why this equals 2 to the 5th. Well, what does 2 squared mean? What is the definition? By the definition of powers. So we're always going to go back to the definition of powers when we prove these rules. So the definition of power says 2 squared is just 2 repeated multiplied by itself 2 times. 2 cubed says 2 multiplied by itself 3 times. And now I'm going to take this multiplication sign and move it down. And what do I have? 2 cubed times 2 squared, 2 to the 2nd power times 2 to the 3rd power is 2 times 2 times 2 times 2 times 2 times 2. And what does that mean? Well, that's 2 multiplied by itself 5 times. Well, that's 2 to the 5th. And so I'm showing you why you add your exponents, because here's 2 3's multiplied together. Here's 3 3's, and if you do multiply them all together, you get 5 3's, because 2 times 2 times 2 times 2 times 2 is that by definition, again, the definition of power, 2 to the 5th. So we use our definition of power to expand 2 squared, 2 to the 2nd power, to 2 times 2, and we expand 2 to the 3rd power times 2 times 2 times 2, and then we apply the power rule again, the definition of power, and we see that it's 2 to the 5th. Okay, so let's do our problems now, looking at it the same way. This first one, I'm just going to do it by expansion. So watch what happens. 3 to the 1 power means 3 repeated 1 times. Here's my multiplication sign. And now we multiply 3 by itself 4 times. And what is this? 3 times 3 times 3 times 3 times 3 is 3 to the 5th. Well, if I'd applied my rule, I would have said 3 to the 1 plus 4, or 3 to the 5th. Okay? So now let's start. We can start to apply we'll apply our rule first. A to the 5th times a to the 4th means a to the 5 plus 4 equals a to the 9th. And let's see why that's true. Well, a times a to the 5th is a times a times a times a times a. And a to the 4th, there's my multiplication, a to the 4th is a times a times a times a. Well, we have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. A to the 9th, lo and behold. So now we don't need to use, now let's not use our expansion, let's just use our rule. So I want you to pause and try these last two. And now I assume you're back, and the answer to this one is b to the 29th. And the answer to this one, look at what we can do. This is, you just add them together. This is, you don't need to just do 2 things when you're using the product of powers rules, but you can use 3. So let's add all these exponents together, and we'll get x to the 10th. Right? Because this is x times x, and there's my multiply, times x times x times x. And then we have times x times x times x times x times x. And that all together is 10 x's, so that's x to the 10th. All right, so that's our first rule. Now let's look at our second rule. Our second rule is called the power of powers. So this is when we take an exponent and raise it to another power, another exponent. We take a base, we raise it to an exponent, and then we raise that to an exponent. Now this is when we do our multiplication thing. So why is this happen to be true? Why is it that we multiply our exponents? Well, let's look at that. Let's break it down one more time. 5 to the 3rd to the 2nd is the same thing. Let's break this down. Well, we take the inside thing and we repeat it, multiply it together 2 times. So this is 5 to the 3rd times 5 to the 3rd. And now we can use the product of power rules, because now we have a base to an exponent times a base to an exponent, and that says we do 5 to the 3 plus 3, which is equal to 5 to the 6th. Pretty cool. And so that's where we get our multiply, because we get 2 times 3, or using, again, a product of powers. Similarly, our x cubed to the 4th is equal to x cubed 4 times. X cubed multiplied 4 times x cubed times x cubed times x cubed. And by the product of power rules, rule number 2 says we just add our exponents, and this is x to the 12th. Now, we could have just used our power of power rules, which we're learning right now, and no, we just have to multiply them. X to the 12th. But instead, we chose to go with expansion just to show you and prove to you the rule about multiplication. All right, now let's do our problems. 3 squared to the 4th. I want you to pause and try each one of these problems. Okay, I assume you've paused and tried, and I really encourage you to try each one of these. If you just sit here and listen, you're going to think you're going to get it, but if you don't go through the process of either doing them and getting them all right or doing them and making a mistake, you're fooling yourself into a false sense of security about knowing math. You need to put pencil to paper. Put pencil to paper. All right. Now I assume you've tried all 4 of these, and you've either gotten them right or you're confused, and or you're going to see how we do these. So let's do it. Well, this is 3 to the 2 times 4, or 3 to the 8th. For those of you who used expansion, you could have said, well, that's 3 squared times itself 4 times. The inside times itself 4 times. And this will be 3 to the, you add all your exponents together and you get 3 to the 8th. So you could have gone either route. This one is a to the 10th, a to the 2 times 5. This one is x squared. It's just x squared. Because on the inside, x to the 1st is just x. That's squared, so x squared is x squared. Either way. And down here we have to do our rule twice. So on the inside, we have a squared cubed is a to the 6th to the 4th. And then we have a to the 24th. We could have done just multiplied all the way out and said, well, that's a times 2 times 3 times 4. And that could have been a to the 24th. So either way. And so that's rule number 2. The power of power rule. You need lots of practice. You need lots of practice with powers. Lots. Rule number 3. This is called the power of products rule. So this says if 2 numbers are multiplied together and you raise them to an exponent, you can just take that exponent and drop it down inside both variables or both expressions. Okay, now the key thing here is it only works if these things, it's a power of products. This is not true. If you said 2 plus 3 to the 4th, that does not equal 2 to the 4th plus 3 to the 4th. Does not equal that. No, this is not true. It only works if they're multiplied together. Okay, let's see why this rule is true. Well, let's take this one and say, well, it's 2 times 3 squared. Let's do the rule. Well, it means the inside thing multiplied by itself 2 times. So, well, that's 2 times 3. And I got to multiply that 2 times. So 2 times 3 times 2 times 3. Because everything's multiplied, I can drop my parentheses. Now I can rearrange using my commutative property, 2 times 2 times 3 times 3. So that's commutative. This is associative. Really, I can just reassociate how I multiply of multiplication, commutative of multiplication. I can move things around. I can drop parentheses as long as it's all multiplied. And now I'm going to use my power rule. Well, 2 times 2 is 2 to the second power. And 3 times 3 is 3 to the second power. So now I've proved that 2 times 3 to the second power is the same thing as 2 to the second power times 3 to the second power. And that's by the definition of power. And so I can similarly show this one here. Let's do this one. This is x times y times x times y times x times y. Or this is by definition of power. The inside thing multiplied by itself 3 times. Now I'm going to get associative on you and just drop my parentheses. Now I'm going to use my commutative, put my x's together and my y's together. And then I'm going to use my definition of power and show you that this indeed does equal that. Again, this was my definition of power. This is associative of multiplication. This is commutative of multiplication. And then this is, again, my definition of power in the other direction. So let's do our problems. I want you to pause and try and do these problems. And remember, you just kind of think of it like this. It's almost like distribution, but it's not really distribution. I'm just going to drop my power right on top of each base or each expression that's multiplied together. So this is 3 squared times 4 squared. This is x to the 4th times y to the 4th. And this is, because there's 3, I could do it 3 times. I get a cubed. I've said that a few times, and I haven't explained this perhaps. But a cubed is equal to a to the 3rd. This just means the same thing. When I say a cubed, and when I say a squared, that means a to the second. Anything to the second power is the same thing as saying that thing's squared. Anything to the 3rd power is saying that thing cubed. I'm not going to get into why. Maybe some of you can put it together. Why? It has to do with the fact that if I have a side that's a in a square, the area is a squared. And if I have a cube with side a, where all sides are a, because a cube is three-dimensional object where all 3 dimensions are equivalent, the volume is a to the 3rd power. So that's why they call a to the 3rd a cubed, and they squared a to the 2nd power. All right, let's go on to rule number 4. Rule number 4 is a combo of rule 2 and 3. And remember, 2 says if I have something inside parentheses, a power inside parentheses raised to another exponent, you just multiply them. And the power of product says if I have 2 things multiplied together and I raise them to a power, then I can simply raise the each expression that's multiplied to that same power. Okay. Now the combo says that, well, if I have something raised to a power times something raised to another power inside, I can just multiply that power, that exponent on the outside by the 2 exponents on the inside. So for example, if I have 3 to the 1st times 4 squared to the 3rd power, I can take that 3 and multiply it by my 1 and get 3 to the 3rd. Take my 3 and multiply it by my 2 and get 4 to the 6th. Likewise, if I'm doing it with variables, I can just take my 2 times my 2 and my 2 times my 3 and get my new variables. And we can try and prove that kind of quickly here. So if we take this inside thing and we repeat it multiplied 3 times, I say, well, 3 to the first times 4 squared times 3 to the first times 4 squared times 3 to the first times 4 squared. Right? That's my definition of power. Now I do my associative by dropping my parentheses because everything again is multiplied. So that's associative. Now I'm going to use my commutative. I kind of been doing the same thing over and over. Put my 3's together, 3 to the first times 3 to the first times 3 to the first times 4 squared times 4 squared times 4 squared. And now this is basically 3 to the first to the third. And this is 4 squared to the third. And we know that 3 to the first to the third is 3 to the 1 times 3. And then 4 squared is 4 to the 2 times 3. So there we go. So now I've showed that this is equal to this by the rule that you basically multiply down your exponents. Okay, so let's do our problems. And I'm going to show you the first one. Kind of remember to do this multiplication and you won't screw up. And down here, you're going to have to think about, well, what's this? This is really a hidden 1, and this is really a hidden 1. Okay, I'll pause and try. Okay, I assume you're back. I assume you've tried this out, and now we have 2 squared times 3 cubed to the second, and we get 2 to the fourth times 3 to the 3 times 2, or 3 to the sixth. Here I get x to the 3 times 4. I'll write this one out and put this one in 2 steps. Haven't been doing that. So that's x to the 12th times y to the 6th. Box my answers. Commit to them. Okay, and here, because this is really at a to the 1, when I multiply down, I get a to the 4th, b to the 8th. That's not a 0. This is not a 0. The 1. So down here I get q to the 2, r to the 4th, t to the 8th. All right, moving on to rule number 5. The quotient rule. This one's interesting. This is kind of like the opposite of the. This is the opposite of the product of powers. Now we have the quotient of powers, and this says that you subtract exponents. You don't divide them. You subtract them. And how can we prove that that's true? Well, let's just look and see that it's true. Because this is 3 to the 5th over 3 squared equals 3 times 3 times 3 times 3 times 3 over 3 times 3. And that's our definition of power. Now we're going to do our simplification. We can cross off on the top and bottom the same things. 3 divided by 3, 3 divided by 3, because that's effectively equal to 1, and that's equal to 1. So we can do our cancellation. And we're left with 3 to the 3rd. So that's by simplification. And then we can rewrite 3 times 3 times 3 as 3 to the 3rd by the definition of power. So we see that 3 to the 5th over 3 squared is not. You don't divide them, you subtract them, because you need to take your 5 3's on top and you're getting rid of 2 of them with 2 3's on the bottom. So we have 5 3's and we're getting rid of 2. So that's 5 minus 2, or 3. All right, so let's do our samples. Similarly, with a to the 7th times divided by a to the 5th, we could just say a times a. You do our 7 a's. Let's just do this one for fun. All over a times a times a times a times a. So there's 7 a's on top and 5 on the bottom, so we'll cancel 5 off the top and bottom, and then we just get two a's left on top, which is a squared. Okay, let's pause and try our samples. Well, here we have, I'm going to do this one by expansion, but you can do it by rule if you want. So we have 4 to the first, which is the same thing as 4. It's by subtraction. 4 to the fourth divided by 4 cubed is 4 to the 1, which is equal to 4. So either one of these is fine. X to the 6th over x to the 4th is x to the 6 minus 4, which is equal to x to the 2. A to the 8th over a is the same thing as a to the 8th over a to the 1st, which is equal to a to the 8 minus 1, which is equal to a to the 7th power. This one's a little bit tricky, but watch what we do. X to the 4th times y to the 4th over x cubed. Y squared is the same thing. We can do this. Look at this, because x to the 4th, I can separate out my fractions, right? These are equivalent, because if we multiply these two together, and we could go back here, we just multiply our numerators and multiply our denominators to get back. So we can separate these out, and now we know what this is. That's equal to x to the 1st. And this thing here, we can see what this is. That's y squared. So we get x, y to the 2nd. We could have gone straight from here straight to there without doing the separation by simply saying, well, this is x to the 1, and this is y to the 2. So we could have gone straight there, but I wanted to show you by separating them out that that was a legitimate thing to do. Okay, let's move along. The power of quotients. So just like if we have x, y to the a equals x to the a, y to the a, we have this rule that says, well, if we divide it, we can do the same thing. We just take our a and put it here, and take our a and put it here. So we get x to the a over y to the a. And how come we can do that? Well, let's take another look. We'll take a look at this 4 over 5 to the 2nd power, and let's just see what that means. Well, that means that by the definition of power, we take the things on the inside and we multiply them together 2 times, because the exponent is 2. Well, we know that this is the same thing as 4 to the 2 over 5 to the 2. And there you have it. So this is by definition of power, and this is by definition of power. And there we have it. Similarly, x over y to the 3rd power is x over y times x over y times x over y. Well, that's equal to x to the 3rd over y to the 3rd. And that's by definition of power. And this is by this is by definition of power. I probably skipped a step for those doing super formal proofs, but we're good enough without having to explain that little nuance here. So let's pause and try right here. Using our rule, well, 2/3 to the 4th power is the same thing as 2 to the 4th over 3 to the 4th. I assume you've tried all these. This is x to the 5th over y to the 5th. And this is x to the 5th over yz to the 5th. Well, we know that by our power of product rule is this on the bottom. It's y to the 5th, z to the 5th, right? So we had to do a 2-stepper, but we could have just done this. We could have just said, well, that's 5 here, 5 here, and 5 there. But I did it in 2 steps to make sure that we really understood exactly what we were doing. All right, now the final rule is a combo of 2 rules, and that's, we've done something like it, and it basically says if you have a power divided by a power, and you raise that whole thing to another power, you can just multiply that power inside and get x to the AC over y to the BC. Another example of that would be 2 cubed over 3 to the 4th. All of that squared would equal 2 to the 6th, multiplying those, over 3 to the 8th. That would be an example using a base that's a number instead of a base that's a variable. So let's look at this one a little bit closer to prove it. Well, that's 2 cubed over 3 to the 4th 2 times. So times 2 to the 3 over 3 to the 4th. And that's equal to 2 to the 3 times 2 over 3 to the 4 times 2. And that's what our rule says. We take the thing up here and we multiply it down into our power that's inside the parentheses. Okay, so let's look at some examples here. And all we're going to do is we're going to do our multiplying inside, and then we have a kind of crazy one over here, but let's see what we can come up with. Okay, so pause and try. Here we got 2 to the 9th over 5 to the 6th. 3 times 3 and 3 times 2. Here we have x to the 8th over what? Well, this y is like a 1 here, or it is a 1. It's an implied 1 over y to the 4th. And here we have to multiply this 5 inside 5 times, once for each variable. So we have x to the 5th, y to the 10th, z to the 15th, over a to the 10th, b to the 10th. So let's do one last slide. We're going to put a few rules together, and then we'll be done. Lots of examples here, lots of stuff that you need to know how to do for the quiz tomorrow on day 9, the day 9 quiz. And so here's all of our rules one more time on the left, and let's see if we can apply them here. I want you to pause and try all of these, and let's see what we come up with. All right, I assume you've tried all 3 of these. So here we're going to just multiply down. This is just rule number 7, really. X to the 8. Oh, it's not really. This one actually, you could have done it in multiple ways. Over y to the 4th. Now, but this here, we can apply one more rule. We can apply our product of power rule and say, well, that's x to the 20 over y to the 4th. Another way you could have done this one is combine these first, use your product of power rule first. So let's just box that. We could have said that, well, that's x to the 5th over y all to the 4th, doing this step first. And then we could have done our multiplication down and gotten x to the 20, y to the 4th, right? 2 approaches, both equivalent. All right, here, let's look at this one. Well, let's start here and get rid of this guy. That's my hint to you. And then we'll write x to the 4th over y to the 5th, z to the 9th, over, this is what? 2 times 2. X to the 4th by the power of powers rule. That's x to the 4th, 2 times 2, over y, z to the 4th. Now we're going to use our quotient rule here, here, and here. Well, x to the 4th divided by x to the 4th, those are the same thing. So we're just going to cancel that. Those go away. Anything divided by itself is just a 1. So here we got y to the 5th over y. And so that's y to the 4th. And over here we got z to the 5th. Now some of you may have said, oh my goodness, and we'll do it the other way here in a second. You may have said, well, I'm just going to use my quotient rule, and I'm going to get x to the 0, 4 minus 4 is 0, y to the 4th times z to the 5th. And then what you're going to say is, well, what is this x to the 0? Well, if this has to be equal to this, So the only way that those are equal is if x to the 0 equals 1. And we're going to learn, so don't let me confuse you there, but we're going to learn about this guy tomorrow. Anything to the 0 power is 1. And we're going to come up with a better proof than this kind of fuzzy proof that we did right now, that this has to be equal to 1. But yeah, let's move forward. Okay, so this one's crazy. We're just going to have to do a lot of math here. So we're going to have to apply things a little bit at a time. Well, let's start here. Let's start with this rule. And so if we apply the combo rule, this is rule number 7, where we're going to do this rule, where we basically take our c and multiply it by all of our powers, or all of our exponents on the inside. We're going to get x cubed y to the 6th over z cubed. And we'll multiply that by x to the 4th, z to the 3rd over x, y to the 6th. Now let's multiply out this numerator. Let's do that next. So this is the same thing as x cubed, and I'm going to use a little commutativity, put my x's together, times x to the 4th. So this x to the cube to x cubed times x to the 4th. And then we'll put our y to the 6th times z to the 3rd. And on the bottom, we'll put these in order as well. X, using commutativity, times y to the 6th times z to the 3rd. Well, y to the 6th over y to the 6th is, those cancel because they're the same. And z to the 3rd over z to the 3rd is the same. Those cancel. So all we have now is, on top we have x to the 7th. X cubed times x to the 4th is x to the 7th over x. So by the quotient rule, that's x to the 7 minus 1, because this is like an implied 1, or x to the 6th. And there you have it. This is a lot of math here that we just did. We did this. This would normally take you, everything that we did with exponents, this is probably a week's worth of math. If you were in a normal math class and you did an hour a day of math, you would have learned all of this across maybe 4 days, maybe 5 days, and you would have practiced heavily. So just having watched this in an hour or 40 minutes or however long this video is, don't expect to get it all and have it all just, oh, this makes total sense, because it takes practice. Exponents are tricky. They're hard to conceptualize, or at first they're hard to conceptualize. They just take practice, and we'll do lots of practice over and over again. So we'll be seeing you in math class tomorrow, and we'll hit you with a few more rules, and then we'll be to get you exponent power masters before you know it. All right. We'll see you next time.